This is probably a little above and beyond the CCENT and the CCNA, but I want you to see NTP broadcast mode in action. Not complicated at all, but one classic little gotcha you got to watch out for. We still have routers 1 and 2 up and running over the 172.12.123.0 network. I did take the NTP server command off of router 2. As a matter of fact, I took all the NTP commands off of router 2. So right now, NTP isn't even running on router 2. Router 1 is still a master. And what we're going to do instead of setting up a unicast communication is set up the master device to broadcast NTP information out a given interface. And the reason I say a given interface is that this is an interface level command. So if you start looking for it with NTP iOS, it's not going to work. What you need to do instead is go this way and use NTP iOS help here. And under the interface, we have broadcast, and then we have some options and the CR. So we know this is a legal command by itself. Here's the little gotcha I mentioned. NTP broadcast is for your master devices, and NTP broadcast client is for your clients. I know that seems obvious, but I'm saying it anyway. Because if you just put NTP broadcast on everything when you've got a master device and some devices you want as clients, but you're using broadcast, then you're just going to be sitting there for a long time because the config will not work. It'll be accepted by the routers, but it won't work. So we'll go with NTP broadcast there, and then down on 2 on the serial interface, it's NTP broadcast client. And as you would expect, I'm going to pause this for a minute or two while router 2 syncs up. Router 2 still has the correct time. You can see there with November 6th and then a timestamp. However, I did get rid of the association, but it still had its time it got from router 1 in a previous lab. So let me pause the video. I'll bring you back when the association's up and running. And we are all set. Router 2, pardon me for a moment, router 2 at Show NTP Association is showing everything we would expect to see. And even more importantly, Show NTP status shows the clock is synchronized. One small difference here, you might look over here and say, okay, where's my squiggly? You know, Chris said we had to have both of those. Well, you have to have both of those if you have an actual server-client relationship configured. But here we didn't do that. Router 1 is sending NTP broadcasts out its serial interface. We enabled router 2 to listen to that in the mode, in the role of a client, but we didn't say NTP server 172.12.123.1. So since the little squiggly stands for configured, we do not see one over here. This address was learned via a broadcast. So just a little bit of a gotcha there I wanted to point out to you with the NTP broadcast and NTP broadcast client commands. That's about it for NTP, period, actually. Coming up next, we are on our way to work with Nat and Pat. You'll meet both of them in the very next section. See you there.